All right, so welcome everyone to free GMAT Prep Hour for December 11th. I'm your host, Avi Gutman. Just a few seconds on this slide to remind everyone that this is hosted by Manhattan Prep, and we do offer a lot of great products. And I wonder if anyone can see a common theme in what we're going to cover today. What's jumping out at you there? You got it, Maddie. Has anyone noticed ratios come up a lot on the GMAT, or is it just me? The slide kind of gives it away. It comes up in algebra, it comes up in word problems, it comes up in number lines. I think usually GMAT test takers don't realize necessarily that the question is testing the concept of ratios, even when in fact it is. And so that's kind of what I want to dedicate tonight's session to. Just spend an hour on ratios and see how they come up in a variety of different question types. So let's get started with this data sufficiency question. It looks like an algebra question. I'll give you a minute or two to work on it on your own, and then I'll hop back on and talk you through it. All right, so that was about 2 minutes for you to work on this question. Any reactions to this? Maybe we can use the chat box a bit here. What are you noticing? What are you thinking when you try to solve this data sufficiency question? I'm not looking to see what answer you would pick, just what are kind of the thoughts that that this question invokes for you? Okay, good. So, yep, they are asking for a ratio. Y over X is a ratio of two numbers. They're looking to know what is that value, what is that ratio. Anurag says be thorough. That's right. So which statement would you all start with? I'm curious. Which statement do you think is easier to work with first? Should we start with statement 1 or statement 2? And why? Why would you make that choice? I'm noticing that many of you are not typing anything in the chat box, and I really want to encourage you to try to answer the questions that I'm asking. I'm really just asking for your general thoughts. I'm not asking you to solve the question. And that's really how you're going to get value out of this session. Otherwise, you might as well just wait for it to go on YouTube and watch it passively. But if you're already here and we're all here together, let's try to get this as interactive as possible. All right, so someone is saying we should start with statement 1 because it gives us a definitive value for x. Someone else is saying we should start with statement 1 because statement 1 can't possibly be sufficient. Let me know in the chat box if you agree statement 1 can't possibly be sufficient. Is that true? Like, looking at what statement 1 is telling us, there's just no way that you'd be able to find the ratio of y to x if all we have is x. Does that make sense? Robert, I see you were saying that as well. Now, one of you wrote that statement 2 is correct. I just want to warn you that the statements are always correct. The question is not asking us, are these statements correct? The statements are always truthful, they're correct. Our job is not to determine the correctness of these statements. It is not a true or false question. What we're tasked with here is determining whether each of the statements on its own is sufficient information in order to answer the question that they started with. So if you meant to say statement 2 is sufficient on its own, then that's valid. I'm not saying that's true, but that's at least something that is relevant. But don't say that statement 2 is correct, because of course it's correct. The statements are always correct. So just a note to be careful in that. All right, so it looks like most of you agree that statement 1 is not sufficient on its own because it only gives us x and we still don't know anything about y. The Manhattan Prep strategy for data sufficiency is to use this kind of grid, because once you've made a decision on statement 1, you can go ahead and eliminate an entire row. So these are the 5 answer choices, and now that we've decided statement 1 is not sufficient on its own, we can eliminate the entire top row there, AD. Before we start going further through this question, I just want to talk for a moment about what ratios really mean on a number line. So I just drew a big red number line here on the slide, and I don't know where 0 is on that number line, but when we talk about ratios, the location of 0 becomes very important. Whereas if we're talking about a difference between two numbers, so just for a moment here, let's imagine that they asked for the difference y minus x. Well, here's x and here's y, and the difference between them is this distance on the number line. And the location of 0 is really not important. It's totally irrelevant if the question were asking for a difference. But when the question asks for a ratio, let's just look at a couple of examples and see why the location of 0 is so important. So let's say that 0 is here, and x is here, and let's say that y is here. So let's assume for a second they're both positive and y is way over here. The ratio of y to x, what that is actually asking us to do is to take the entire purple distance, that purple distance represents the value of y, and divide that purple distance by this green distance that represents the value of x. So the ratio of y to x is really dependent on the location of 0, because the location of 0 is what kind of determines the purple distance and the green distance. And we're looking for the ratio of the purple distance to the green distance. If, on the other hand, 0 was actually somewhere in between y and x, what would that mean for the ratio of y to x? Let's say 0 was here. Use the chat box to tell me, what can you say for sure about the ratio of y to x in this scenario that I just drew? Good. So a few of you are correct there in the chat box. The ratio would be negative, and this is because y and x are now on opposite sides of 0, meaning they have opposite signs. There's one more thing we can say about the ratio, not just that it's negative. So note that the distance of y from 0 is smaller than the distance of x from 0. X is farther away from 0 than y is. You see that? You can kind of see it on the number line. And so that would mean in our ratio, the numerator is smaller than the denominator in terms of its magnitude, in terms of how far it is from 0. Note that in reality, the numerator is actually bigger than the denominator because y is to the right of x on the number line. So technically, we should say y is bigger than x because y is positive and x is negative. But in terms of their distances from 0, y is closer to 0 than x is, meaning it's smaller in absolute value, if we want to use technical terms. The overall magnitude of y is smaller than that of x. So what does that tell you about the ratio? We know it'll be negative, but can you kind of find a logical range of where that ratio has to sit on the negative side? Could it be negative 100? Could it be negative a quarter? One or the other? What can you infer about the size of that ratio, given that the purple distance is smaller than the green distance? You got it, exactly. Good. You guys are good. So we would say in this scenario that the ratio y over x is less than 0, because we know that it's negative, but it also would have to be greater than -1, meaning it's some sort of negative fraction between 0 and -1. We can tell that just from looking at this number line. Okay, so we're looking for a ratio, and therefore the relative location of 0 relative to x and y is going to be very important. All right, let's look at statement 2 now on its own. There's a really kind of interesting and funny phenomenon that happens when we have an even exponent. I like to think of even exponents as if they hide, let me type this here for you, even exponents hide which side of the number line the variable lives in. Okay, so I'm imagining this west versus east, if you're into rap, or you know, we've got two sides of this number line, the positive side, the negative side. Maybe there's some sort of Star Wars metaphor or analogy that you could use here, the dark side, etc. And when you square a number, or when you raise it to the 4th power or the 6th power, really any even exponent, you're going to lose some information there. You'll of course get something that is positive at the end, or 0, but you can't possibly get a negative number when you raise an unknown value to a even exponent. Because if it were negative to begin with, and you're multiplying it times itself an even number of times, then all of those negative signs cancel out, and we end up with a positive. So for that reason, I would say that, actually, I'll ask you to type in a chat box, what can you infer from statement 2 about x and y? Given that they have even exponents in this equation, what can you say for sure about the values of x and y on a number line? So let's do this all in the context of a number line. What can you say about the locations of x and y? So you're right, Maddie, that x squared and y squared would both be on the right side of 0. They can't possibly be on the left side of 0. What I'm looking for, though, is an inference about x and y. So they're telling us something about x squared. They're telling us something about y squared. But the question wasn't about x squared and y squared. The question was about x and y. So how do we go from the information in statement 2, which is talking about x squared and y squared, to just x and y on their own? How do we make an inference there? So one of you in the chat is saying that 0 must be between x and y. I actually can't say that from statement 2. I don't know that 0 has to be in between them from statement 2. Anurag and MS and Zain are all correct. And Robert as well. Really well done. So what we can tell for sure is that x and y have the same distance from 0. We can't say which side of 0 because of those even exponents that are hiding that piece of information. There's just no way for me to tell which side of 0 x and y are on from statement 2. But what I can say is that their distances from 0 are the same. So an equivalent statement to statement 2 would be to say that the absolute value of y equals the absolute value of x. That is exactly the same thing as what statement 2 is saying. So what can you say about the ratio of y to x if we know that they have exactly the same distance from 0? What can you say about the ratio? What must it be? When two numbers are exactly the same distance from 0, again, we don't know which side of 0, but they are the same distance from 0. What does that tell you about the ratio? It does say a lot. It says a lot. So Maddie and Keith, what do you think about what Anurag said in the chat box? Does the ratio have to be 1-to-1, or is it possible that it is -1? That's right, it can be negative as well. That kind of goes back to the example that I had down here on the number line where we had y and x on opposite sides of 0, and in that case, the ratio would be negative because they have they have opposite signs. And so we can kind of answer the question at this point, but not really, right? We can say the value of y over x is either 1 or -1, just not sure which. So is that good enough on the GMAT for data sufficiency? Can you say, well, it's either 1 or -1? Does that count as being able to answer the question? That's right, it's not enough. So statement 2 is not sufficient on its own. It's almost sufficient on its own. It narrowed it down really nicely to just 2 options, but still not quite sufficient. So now that we've shown that neither statement is sufficient on its own, it's time to combine the statements. And this is a good point, a good place to remind you or warn you that we do not want to combine the statements any sooner than that. This is a very common mistake that people make. They combine the statements prematurely. The truth is that in most data sufficiency questions, we don't need to combine the statements at all, because 60% of the time, the answer will be either A or D or B. Only 40% of the time, approximately, the answer will be C or E. And only in those cases, we would need to combine the statements. This is one of those cases, though. We've already eliminated the other 3 answer choices. We're down to C and E, so we should combine the statements. We know that x is 6. We also know that x and y are the same distance from 0. So I'll say that either x and y are both 6. That's one option. Or the other option is x is 6 and y is -6. Okay, so the first option gives us an answer of 1. The second option gives us an answer of -1. So we still can't definitively answer the question, and we'll pick E. Any questions or reactions to what we just saw? One reaction might be that we didn't really use algebra to solve this algebra question. I think that would have been my reaction. But that's I think really the only way to improve our quantitative reasoning, is to really think about number lines and what it all means, and kind of learn, improve our reasoning that way. Because with algebra, we're kind of gonna stay at the level that we're at, if that makes sense. In other words, whatever algebra you are able to do, well, that's the algebra that you're able to do, and that's it. But if we want to really improve our score significantly, we have to start thinking about ways to improve our reasoning. All right, great. So let's look at another GMAT question that is kind of testing ratios. No, Robert, when I say algebra, I don't mean plugging in, although that is another approach that you could use here. I would say both for algebra and for testing cases, which I think is what you meant, Robert. Those are great approaches on test day, but they're not that great when you're preparing for the test, because if you're able to solve it by testing cases at home, then you're able to solve it by testing cases at home, but then you didn't learn anything from it, if that makes sense. Same goes for algebra. So when you're studying at home, I think it's a good idea to draw number lines and really think deeply about the situation. Let's try this one. Any reactions to this data sufficiency question? Another one that looks like algebra. Curious whether anyone tried to rephrase the question to is 2m equal 3n question mark. So what I did there is I added 3n to both sides. Good. Did you notice that I copied, or I kind of wrote the word is in front of it, and I copied the question mark there? This is really important. I've found that when, particularly when questions are a little bit more complicated, if I don't write the word is, if I don't copy the question mark, I get confused, I get turned around, and I think that, I accidentally think that this was given to me as a piece of information. When in fact it's the question, it's what the question is asking. So this is just a good habit that I developed after making mistakes once too many. Now I'm getting a suggestion in the chat box to start with statement 2. I see why you would want to do that. If you notice that statement 2 is just an expansion of what they're asking by a factor of 3. If you don't notice that, I think you actually should start with statement 1. Why? Why would I like to start with statement 1? Any ideas? The way that I would say it is that if all I know is that m isn't 0, if that's all I know, how can I possibly answer that question? it doesn't give two values, it gives an infinite number of possibilities. All they're saying is m isn't 0. Okay, so is 2m equal 3n? I don't know, there's two unknowns still. Statement 1 is just really grossly insufficient, I would say. So yeah, I think you can start with either statement. What I wanted to show you for this question, though, this question I think is a lot easier than the previous one. We can kind of, well, we just saw statement 1 is not sufficient on its own, and statement 2 is, because as some of you said, if you just reduce this equation by a factor of 3, you get exactly what they're asking. So, so the answer is B. But what I think is interesting here is we can continue to rephrase this question a little bit further if we wanted to. We could divide both sides by n, and I'm not really allowed to do that because I don't know that n isn't 0, and if n is allowed to be 0, then I'm not allowed to do this. But just for didactic purposes, let's imagine that we know neither m nor n is 0. So if I were to divide both sides by 0, I'll get this. And then if I divide both sides by 2, I get this. And this is starting to look a lot like a ratio. I might even write it horizontally. I might say m to n is 3 to 2. And so there's something interesting that I want you all to notice here. M to n is 3 to 2 is a ratio. And it means exactly the same thing. Again, assuming that n is not 0, it means exactly the same thing as this equation. And I think that for most people, when they look at this equation, it doesn't really scream ratios at them. And I think that it should. I think it's a good idea for the GMAT to look at an equation like that and immediately recognize, hey, this is giving me a ratio. And knowing how to go from that equation to the ratio, you'll notice that the numbers kind of flip when we get from the equation to the ratio. And then we can see statement 2 also gives us a ratio. And from there, I would say, well, if I have the ratio of m to n, then I can answer this question about the ratio of m to n. Because really, it's just they're asking for the ratio of m to n. Is the ratio of m to n 3/2? And here they're giving me a ratio of m to n, so it's going to be sufficient. So that's really all I had to say about this question. Any reactions or questions about that before I move on? Okay, let's look at the next one. Oops. So another ratio question, but this time a problem solving as opposed to data sufficiency. In this one, what I wanted to show you is if I take what they gave me and rewrite it horizontally like this, so x to y is 2 to 3, I can, if I want to, tack on another column there. So I call this taking a two-way ratio and turning it into a three-way ratio. And I can do that. So in the world of ratios, x minus y would have exactly -1 ratio units. Just to kind of illustrate this point, I'll tack on another column, although this next one is not necessary for this particular question. But I could say that together x plus y would be 5 ratio units. And if I wanted to really go nuts, I could go ahead and say that 3x plus 5y would be, what is it, 21 ratio units, if I'm not mistaken. So all I'm doing here is I'm using the original numbers that I have in my ratio for x and y and plugging them in as I expand this ratio further and further. We can do this as much as we want, and that's really a concept that I see tested in the GMAT a ton. This question is no exception. Because if we do what I'm suggesting here, then we can just grab the x minus y from here and the x from here, and we have our answer. Our answer is -1 divided by 2. So, hey. You're welcome, Bilal. Any other reactions to this? No, Jay, I really can't think of a situation where this would not work. It has to work. And I want to give you, I wonder, is anyone here old enough to have used those paper maps that had a scale usually in the bottom right corner? There was a scale that would show, 1 inch is 20 miles or something like that. Do you know what I'm talking about? Those atlas books from 20 years ago, from before GPS. Yeah, Bilal knows it. I used to be a flower delivery guy back in the 20th century, long time ago. And there was no GPS, so I would use these physical maps. And that's kind of what's going on here. It's the same kind of concept. You see in these maps, you'd have, let's say, each inch represents 20 miles. Well, that's a ratio. That's a ratio. You can think of the inches on the map as ratio units. So 1 inch, 1 ratio unit, translates into 20 miles in the real world. And so you could look at a map of, say, North America, and you would see that Toronto is, 3 inches from Boston, and Toronto is also 3 inches from Chicago. And so then from that, you could say, I don't know how far they are in real life, but I can say that Boston is just as far from Toronto as Chicago is. Those distances are the same. And you could say that if I add those distances together, then I'd get the sum of those distances, again, in the inches. So anything that's true in real life with real miles or real kilometers is also going to be true with those inches, with those ratio units on the map. I don't know if that helps or if it just confuses you. Maybe you can let me know in the chat box if that analogy makes it easier to understand why this works, like why we can do this. The ratio is really just a model of reality. It's just a representation of reality to make it simpler, just easier numbers, just as we can use inches on paper to represent miles. Cool. All right, good. So let's look at a word problem. All right, so I didn't mention earlier, but in problem-solving questions, I always start with a glance at the answer choices, just to see if that gives me any hints. And in this case, I would say this is a hint. I would say that I know now this is a ratio question, because percents are ratios. A percent on its own is meaningless. A percent is always out of something. This is the same thing as a fraction out of something. It's a ratio. I also notice fractions in the question stem, so I know that this is a ratio question. And for that reason, I'm thinking that this number 3600 is probably not that important. To Jared's question in the chat box there, yes, this is a real official GMAT question. All of the questions we're looking at today are questions from the test. If you find this question to be very easy, then that's great for you. Some people find it easy, some people find it very difficult. If you're new to the GMAT, I will mention it's an adaptive test, a computer adaptive test, which means that if you do well, if you answer the questions correctly, the questions will get harder and harder and harder. And if you don't do so well, the questions get easier and easier and easier. Different people find different questions to be hard or easy in my experience. I don't even try to assess the difficulty level of a question because I'm really bad at it. Sometimes I think a question should be very easy for everyone and it's actually really hard and vice versa. So yeah, different people find different questions to be easy or hard. All right, so I want to show you how I would kind of build ratios to digest each of these sentences, starting with that first sentence that I put in a blue box. So what that is telling me is I have a ratio of 1 to 3. So let's do that. So 1 to 3. The 1 represents the clerical out of the total employees. So let's call it clerical out of total. 1 out of 3. 1 to 3. So far, so good. Any questions about how I did this? Just from that first sentence? If the answer choices had actual numbers, I would also put the 3600 below the 3, kind of like that, and then I would be able to figure out what the scale is. Remember the scale in the map that I was talking about that shows how many miles each inch is worth? How many employees is each ratio unit worth here? Can anyone tell? Again, we don't need that for this question, but in other questions we will. So each of these ratio units is worth how many employees? That's right. What we do is we divide the actual number of employees by the number of ratios, and that would give us a scale of 1200. And then if we wanted to know how many are clerical, we would apply that same scale because it's in the same map, and the answer would be 1200. But we don't need any of that for this question because the answer choices are percents. All right, keep reading. If the clerical staff were to be reduced by 1/3. So I already have clerical here. I have 1 ratio unit for the clerical staff, but now I need to reduce it by 1/3, and that's not fun. I don't like to work with fractions in general, and I especially wouldn't work with fractions inside a ratio. So maybe I want to rethink these two numbers. The beauty of a ratio is it's just a model of reality, and I can play around with that model. I can scale it up, I can scale it down as I see fit. So if I prefer, I could use 10 and 30, or 100 and 300, or 2 and 6, or 3 and 9. I can really use any numbers I want as long as they fit that ratio that they provided in the first sentence. So I don't want to read any further. Let's just focus on this part that I'm highlighting in red. Who can help me decide what would be a better number to use in our model to represent the clerical staff? What would be a number that would really be easy to reduce by 1/3? I'm getting some great suggestions. So Anurag suggested to use 3. We could reduce 3 by 1/3. 1/3 of 3 is 1, so we just reduce it from 3 to 2. Jay's suggestions are good as well. Jay suggested to use 30 here. Reducing 1/3 from 30 would get you 20. He suggested using 12. Reducing 1/3 from 12 would give you 8. So those are all great suggestions. Maddie, those are good suggestions as well. Ultimately, I think the best suggestion is the smallest suggestion, which was Anurag. So instead of 1 and 3, I'm going to use 3 and 9. So that no longer exists. I rethought my initial ratio and decided actually I want to call them 3 and 9 because 3 is going to be very easy for me to reduce by 1/3. So that's going to be 2. So our original number of clerical employees was 3, and now this hypothetical situation, if the clerical staff were to be reduced by 1/3, so that would be 2. What would be the total number of employees at this point if we reduced, in this hypothetical scenario, if we reduced the number of clerical employees from 3 to 2? What would be the total number of employees in this hypothetical situation? How many inches of this map did we lose? How many ratio units in this hypothetical scenario are we losing? I'm seeing some students struggle with this. So what I'll suggest is that we state an assumption that we're making here. I think we need to make an assumption that the non-clerical employees remain unchanged in the hypothetical scenario. Okay. And it might even be helpful to tack on another column for the non-clerical. So in the original scenario, if 3 are clerical out of the total of 9, then there are 6 non-clerical. And we're using an assumption that nothing's changing there. Does that seem like an okay assumption for me to make? What do people think? If the question doesn't mention anything about the non-clerical, then presumably they're remaining the same. Bilal, to your question, if we have 3 apples and that number is getting reduced by 1/3, so why would it get reduced by 1/3? Maybe Avi ate 1/3 of those apples. Does everybody agree that that would reduce the number of apples by 1/3? So how many apples do we have now? This analogy is making me hungry. Bad idea. Does that answer your question, Bilal? Okay, great. So that's how we got the 2 here. And the non-clerical remains 6. So then what's the new total, everybody? Who's loving this idea of tacking on additional columns to our ratio to make inferences? Anybody loving that? I have to say that I use this method probably at least 8 times in a quantitative reasoning section that has 31 questions. Okay, great. So now I'm ready to keep reading. What percent of the total number of the remaining employees? So the remaining employees, what's the remaining employees? The total number of remaining employees, what are we using for that? What number do we have for the total number of the remaining employees? What's that? Is it the non-clerical or is it the total? Yes, Bilal, I got the 6 by subtracting, I shouldn't use that color, sorry. I got the 6 by subtracting 3 from 9, that's right. So the idea is that the total employees is clerical plus non-clerical. So we've got 3 clerical out of a total of 9, there must be 6 non-clerical. What does this purple part refer to? The total number of the remaining employees. It's this, it's the 8. Total number of the remaining employees. So we had 3,600 employees to begin with. And now what used to be 9 ratio units is 8 ratio units. So remaining employees is 8 ninths of 3,600. And of those 8 ratio units, they want to know how many would be clerical in this hypothetical situation. So they're asking what percent is this 2 out of 8? So 2 out of 8 is a quarter. And I think we probably, most of us know a quarter when we see it. I'll just pause here for questions. I think this one was tougher for most of you. Jared, I'm curious, was this question harder than you initially thought it was, or was this really quite easy for you? Because it looks like for others, this was really hard. Maddie is asking a great question. Maddie is asking, is it okay to use the number values to solve as well? So absolutely, it is okay to use number values to solve as well. I suspect that if you can't solve it this way, you probably also would not be able to solve it with the number of values because you'd make the same kind of mistake that you would make here. I could be wrong about that, but I suspect so. And this is always going to be faster than using the actual values. So I would probably advise against using the actual values. But I mean, it's certainly possible to solve it using the actual values. Jay, I think what Maddie meant by number values is to use the 3,600, right? So a third of 3,600 is 1,200, so you would use the actual numbers instead of ratios. And yeah, so Jared is saying he used the actual numbers and it was slower. All right, other questions. We got 8 by adding 6 and 2. Yeah, so you can get this 8, either by adding the 6 and 2, or you can just get it by subtracting the 1. So let me just spend another minute on this because I think it's an important point. We didn't really need this column. I added this column here on the right because some of you were having a hard time coming up with the 8. So I drew this extra column at the same time that I came up with this assumption that we were making. That again is a fair assumption to make on this question. We could have gone directly from, let me just block this off in a box. So what we could have done just with this part, just with that, is we could have said, look, there are a total of 9. 3 of them are clerical. If we fire one of those clerical employees, then there would only be a total of 8. And so literally imagine it's a startup company. It only has 9 employees. 3 of those 9 employees are clerical. We had to fire one of the clerical employees. Now there are only 2 clerical employees out of a total of how many? Well, 8, because we fired a person. We fired an employee. Does that make it easier? This extra column, the assumption, I just added all of that in case this was harder for people to see. But this is why we end up with 8, the total number of remaining employees. After you fired someone, you have 8 total employees remaining, of which 2 are clerical. All right, good. I think we have time for one more, another word problem perhaps. There it is. All right, so from my glance, I can tell that the actual numbers are going to be important here. There's really only one actual number in the question, so I'm going to have to use it at some point to solve the question. But as I start reading the word problem, really I would only read up to the comma, and I would say, okay, this is a ratio, so I've got a ratio of 1 to 2. What's the 1 and what's the 2? Well, the 1 is the investment in stocks, and the 2 is the total. Right? So that's what I have so far. Then I keep reading, and at that point, I'm starting to regret my choice of numbers in my model, because a quarter of what in bonds? A quarter of what goes into bonds? Total. That's right, but my total is 2. So then maybe 2 wasn't such a great number to use for my total after all. What would have been a better number to use for total? So if you're saying 20, I suspect you already read further. But I think that as the questions get more complicated, we're going to benefit from reading the word problem in just very small chunks at a time. I don't want to read all the way to the question mark. I only want to read one part at a time. And so for now, I'm going to call that 4 and 2. And then I can say that the bonds is 1. Because all I've read so far is up to here. So instead of 1 and 2, I used 2 and 4. And the reason I wanted 4 there is because a quarter of that is going to be nice and easy. Then I read on, and then indeed, as some of you have already suggested, I will be using 20, because when I get to here, I'm thinking, 1/5 of 4, that doesn't work out really nicely. I do want to still keep it a multiple of 4, because I'd like to keep all of these nice integers, but I want it to be a multiple of 4 from which I can take 1/5 very easily. And so 20 is indeed the number that I'm going to use. And if the 4 turns into 20, then the 2 is going to have to turn into 10. And the 1 is going to have to turn into 5. And now I can put in the mutual fund. I'll use M for mutual. And 1/5 of 20, that is 4. Okay. And then they talk about the remaining, or what remains. What's the remaining? How many ratio units remain? That's right, only 1 ratio unit remains. So how did I get 1? I did 4 plus 5 plus 10 is 19. Out of 20, there's 1 ratio unit remaining. So Jared is asking a good question. Is it always wrong to use the actual values? It's never wrong to use the actual values, but the GMAT is a test that gives us only 2 minutes per question. So any place where we can use shortcuts, we probably should. I think you're also much less likely to make careless errors if you use smaller numbers, smaller integers that fit the ratio. Because as the numbers get big, it doesn't just take longer, it also increases your chances of making a careless error. All right, so now I know that this 1 ratio unit that remains actually equals 10K. So again, going back to the map analogy, 1 inch is 10 miles. And so what are they asking for? The total amount? Well, if 1 inch is 10 miles, then 20 inches would be 200 miles. And so the answer is C. Any reactions to this one? I think some of you read all the way to the question mark and noticed that the denominators were 2, 4, and 5, and you asked yourself, well, what's a nice integer that is divisible by all of those, 2 and 4 and 5, and you thought of 20, and so then you maybe used 20 ratio units right from the beginning as your total, and I think that's great. So in other words, I encourage that. That's how I would have done it as well. But if you're just starting out with ratios and with all this kind of stuff, I do recommend going one step at a time and not trying to do too many things at the same time. As the word problems get harder and more complicated, it becomes really important to pause and do some work, and pause and do some work, and pause and do some work. And when you do that, then by the time you get to the question mark, you already have your answer. That's kind of what happened to us here. By the time we got to the end, we already had the answer. So yes, the 4 under the T stood for the total using the scale. So each color here had a different scale, right? The first color there was pink, and that had a certain scale, and then I expanded that scale by a factor of 2 for the blue. And then I expanded that scale by a factor of 5 for the green. So it's just like in an atlas, when you flip through the maps, they don't necessarily all have the same scale. You could fit the entire globe, the entire world on you know, a double-sided, like a two sides of a book, but you could also just fit Texas in those pages, and that would just have a different scale. So that's what's happening here, is we're zooming in or zooming out, depending on how you look at it, as we go from pink to blue to green. Nowadays, you just take your iPhone or whichever device and you know, do this with your thumb and finger to change the scale. And that's what we're doing there. Does that answer your question, Bilal? So Jay, what you did is correct. You can do that. Right? 1 over 20 is equivalent to 10,000, and therefore the total is 20 times 10,000. So that's correct, but you had to work with fractions, and I don't like to work with fractions. Bilal, what did you want me to elaborate more on? And William, I'm afraid we won't have time for one more. We'll just do takeaways and wrap it up. Yes, you would be able to solve this with an algebraic equation, MS, but I'm not going to be doing that in this session. Robert, under M, why is it 4? Why is it not 1? So it said 1/5 in a mutual fund. So 1/5 of what? Well, we decided to use 20 there. So 1/5 of 20 is 4. Okay, so here it was half. Here it was a quarter. So that's why this was 1, this was 1. But this is not 1/20th of 20, it's a 1/5 of 20. So that's why it's 4. So Bilal is asking, the T could have been 5 from the mutual fund, and we could have still gotten the same result, right? If we had started with a mutual fund ratio. Yes, that's correct, Bilal. So in other words, doing it in a different order shouldn't change your answer. That's right. Yeah, my pleasure. All right, so to wrap things up, let's look at some ratios, at some takeaways. So I think the obvious takeaway from today is that the concept of ratios comes up a ton, even when we don't realize it. We saw that any fraction or percent can be rephrased as a ratio, and if it can be rephrased as a ratio, it probably should be rephrased as a ratio. And finally, zooming in, we can turn all fractions into integers, and that's an important takeaway for, who was it who was doing 1/2 plus 1/4 plus 1/5? Jay. This is a good takeaway for you, right? So instead of having to do 1/2 plus 1/4 plus 1/5 equals 19 over 20 with common denominator and all that kind of stuff, instead of all of that, we just kind of zoomed in using different scales in order to basically make our life easier. Right? So we're building a model of reality, and we're using the smallest integers that fit that model to make our life easy. All right, Perfect. Well, thank you all for joining me here tonight, or in some of your cases this morning.